In our last update, we discussed what sharding is, the problems it aims to solve, and some of the hurdles we need to overcome to effectively implement it. Today we'll look at cross-shard transactions, invalid transactions, and malicious behavior. The basic type of shard we described in our last article isn't a very useful or practical method of sharding, because they can communicate with each other, which makes them as useful as one individual blockchain. Let us take the example of making a simple payment. If user A and user B were on the same shard, the validators within the shard would be able to process the transaction without issue. But what happens when they have accounts on different shards? User A is on shard SHARP1 and user B is on shard SHARP2. The validators on the individual shards would not be able to debit or credit the user's accounts because they would have no authority on each other's respective shards. There are, however, solutions to this problem, so let us take a look at some of them in a little more detail. Synchronous, same time, cross-shard transactions. In this case, when user A on shard SHARP1 needs to send funds to user B on shard SHARP2, the blocks in each shard that contain state transition that is related to the transaction itself are produced simultaneously, and the validators on each shard work collaboratively to confirm the transaction. Vitalik Buterin proposed merge blocks with this solution back in early 2018. Asynchronous cross-shard transactions is a slightly easier operation to complete, and far simpler to coordinate, so it is more popular than synchronous transactions. Again, we'll use the example of user A on shard SHARP1 wanting to send money to user B on shard SHARP2. In this scenario, the shard in charge of crediting user B's account will only validate its part of the transaction once it has enough proof that the shard in charge of debiting user A's account has been done. This approach is not perfect though. There is a non-zero chance that one of the blocks of one of the shards gets orphaned. A non-zero chance, however unlikely, is still a vulnerability that can be ignored. Taking the figure below into consideration, we'll look at why this blockchain has two shards, and by pure coincidence, they both fork at the exact point that the transaction is incorporated into block A in shard SHARP1 and block X in shard SHARP2. When a fork like this happens, the shard has to orphan one of the chains and accept the other. In this case, if chain A, B, etc. becomes the accepted chain in shard SHARP1 and chain W, X, etc. becomes the accepted chain in shard SHARP2, then the transaction gets finalized and everyone is happy. If the A, B, etc. chain in shard SHARP1 is accepted and chain W, X, etc. in shard SHARP2 is accepted, then the entire transaction fails, which is also an acceptable outcome, because the transaction can be resent. What happens if chain A, B, etc. is accepted in shard SHARP1 and chain W, X, etc. is accepted in shard SHARP2? One part of the transaction is finalized, A, B, etc., and the other part of the transaction is abandoned, W, X, etc. Is that it? Now that you have a better understanding of sharding and H, you can read full post on Cryptophans News, link available in text below.